Hi, I'm JJ, aka the Int Programmer. Jeremy Howard's first lesson in Fast.ai is to train a neural network to distinguish between pictures of cats and dogs. He had us train on over 10,000 pictures of each and achieved an accuracy of over 99% very rapidly. I feel he does a great job of showing us how to build a classifier to recognize images of just two classes, like cats versus dogs, men versus women, trucks versus sedans, desktops versus laptops, etc. He then teaches us how to do multi-class classification in his later videos. I won't go over how to do this, as Jeremy demonstrates it very well in his video, which is linked in the video description below. But the biggest challenge in applying this is, how do you come up with 10,000 images of each class to train on? Let's say you can download and prepare 10 images a minute. You'd be using up nearly an entire day, gathering a total of 20,000 images. So in this video, I'll investigate whether you can get away with training your image classifier on a much smaller data set, say 1,000 or even 100 images of each class. Now let's launch the Jupyter Notebook. Alright, we're at the Jupyter Notebook, and let's initialize some variables. I'll be copy and pasting these from another Jupyter Notebook, since I've already done this using IPython earlier, but I'm just going to demonstrate how to classify dogs versus cats using a limited data set here. This is the cell where we initialize our variables, and you want to set the path to where you put your dog and cat images that you downloaded in the link below. I'm going to have a link below to where you can download this data set in the video description. And let's see, just to make sure, there's a train and a valid folder in the dogs cats folder here, which contains your training and valid sets. And just to make sure, we should have dog and cat folders in both the training and the validation folders here. And this function, you don't have to worry too much about it, but this is just a helper function I built to help wrangle the input data so I can put it into the Fast.ai libraries. Now we create lists of file names of the training and test sets for the dogs and the cats respectively. Now here's where we generate the variables that we're going to input into our model later on. And keep in mind here, I'm going to remove the temporary directory that Fast.ai creates every time, which caches some of your results, and this can skew some of your training if you don't remove this. And the key variables to pay attention to here are f names, which are the names of the files, y, which is a NumPy array that contains the target labels ordered by the file names. And you can see here a cat, I use dummy variables here, but cat equals 0 and dog equals 1. Classes, this is just a list of all the classifications and labels, and you're just going to get 0 and 1 here. Val indices are the images to be used for the validation set. So let's do that. Next, we're going to set up our model. And this might take a while, so I'm going to pause the video and come back. Okay, now we're back, and here's the code which trains this model for 5 epochs at a learning rate of 0.01, and let's see what we get. So we end up with an accuracy of about 0.9885, and this is on 1,000 images. Now let's see what happens if we decrease this to 100. Are we still going to get that high of an accuracy? Now let's train it this time on only 100 images. Wow, we still get 97.7% accuracy. Now next, let's try training it on only 100 cats and 1,000 dogs. Let's see how this goes. Okay, now that the model is set up, let's train this one. (97.65% accuracy, similar to what we got with 100 images of both cats and dogs. Now, let's flip those around and do 1,000 cats and 100 dogs. Okay, now that this model's set up, let's train it. (95.4% accuracy, a little less than what we got using 100 images of both dogs and cats, but still pretty reasonable for a very lopsided data set of 1,000 cats and 100 dogs. Now let's go and see how did Jeremy do in the Fast.ai course.
So here are the 3 lines of code necessary to train a model. And so let's go ahead and run it. So I'll click on the cell, I'll press Shift Enter, and then we'll wait a couple of seconds for it to pop up, and there it goes. Okay, and it's training. And so I've asked it to do 3 epochs, so that means it's going to look at every image 3 times in total, or look at the entire set of images 3 times. That's what we mean by an epoch. And as we do, it's going to print out the accuracy, is the last of the 3 numbers it prints out on the validation set. Okay. The first 2 numbers we'll talk about later. In short, they're the value of the loss function, which is in this case the cross-entropy loss for the training set and the validation set, and then right at the start here is the epoch number. So you can see it's getting about 90% accuracy, and it took 17 seconds. So you can see we've come a long way since 2012. And in fact,
So like Jeremy said, we've come a long way since 2012, and he managed to get an accuracy of 98.9%, and that was on the entire data set of 11,500 images of both dogs and cats. And we managed to get accuracies of about 1% less than that, with only 1/100th of the images that he got. And I was I'm kind of still surprised by this result. I was expecting it to be maybe 80% accuracy or 85%, and I only get 1% less. So what's the takeaway here? Well, you're probably not going to be recognizing images of dogs and cats in your image classifiers, but whatever you choose to do, say you get pictures of, if you're trying to classify between desktop computers and laptops, or say between oranges and apples, you can train on maybe just a few hundred images of each. And you can even get away with training a lopsided data set, having more of one class than the other, and still end up with a fairly competitive result. Now, if you actually go to the Fast.ai lesson, which will be in the links in the video below, you actually can train a model with a much greater accuracy, and Jeremy will show you how to proceed even further with this to increase the accuracy. But I'm not going to reinvent the wheel and show you that. I'm just going to demonstrate that you can train a pretty competitive model on a small data set here, and that's it.